Hello, my name is Alfred Aho. I'm a professor in the Computer Science Department at Columbia University. I've been doing research, teaching, and writing books about compilers all my professional life. Today, I'm delighted to introduce to you Gaurav Gautam, a graduate student here at Columbia who has been helping me teach the introductory and advanced compilers courses. Last summer, while at Microsoft, Gaurav implemented, using Microsoft's new Phoenix environment, a wonderful educational tool called CompilerScope that can be used to graphically illustrate some of the complex code generation and optimization algorithms in the back end of a compiler. Gaurav will now show you some of these algorithms that I teach in my compilers course using CompilerScope. Here is Gaurav Gautam.
I'm going to talk about a new tool called CompilerScope, with which you can look inside the compiler while your program is being compiled. This tool makes learning and teaching compilers both easy and fun. It's an interactive GUI based tool that lets you see what's going inside the compiler. In this presentation, I'll talk about this tool and we'll use this tool to learn compiler optimizations.
CompilerScope is a graphical tool that helps you look inside the difficult to understand parts of a compiler. Let's start with the bird's eye view of compiler. A compiler is a program that translates the program written in high-level languages like C, Java, etc. that we understand into the low-level programs like assembly code that machine understands. Zooming into the details of this translation process, it is a two-step process. In the first step, the high-level program is translated into an intermediate language, which is also called IR. In the second phase, the intermediate language program is translated into the low-level program. The first part of translation is done by the first part of compiler called compiler frontend, and the second phase of translation is done by compiler's second part called compiler backend. In this presentation, we will mainly focus on the compiler backend. Let's look inside a compiler backend in detail. The backend takes an intermediate representation as input and produces the low-level language as output. Inside backend, the IR undergoes a series of transformations. Each transformation changes IR to some extent. The gradual series of transformations together result in the translation from IR to low-level language such as assembly code. The CompilerScope helps you to look across each transformation phase. It helps you to see the IR before and after the phase. A transformation can also be an optimizing transformation which optimizes the IR so that the program runs faster. We'll use CompilerScope to learn some of the optimizations. Phoenix is a framework by Microsoft to build compiler backends. To look inside the backend, we choose a compiler with Phoenix designed backend. CompilerScope is designed to work with Phoenix integrated backends. A Phoenix based backend takes as input a special form of IR called Phoenix IR. This slide shows an example of Phoenix IR. It can be seen that the Phoenix IR does not look much different from the general representation. The statements after the comment shows the corresponding representation in the general IR notation seen so far. A flow graph is a graphical view of the structure and the control flow of IR or program. It helps us to visualize the structure of program by explicitly showing the flow of control at each control point in the program. This slide shows an if-else construct on the left hand side and the corresponding flow graph on right hand side of the slide. The slide shows another example of flow graph of a loop construct. Note that the looping edge in the flow graph helps us to see clearly that there is a loop in the program. Let us now look into the details of the CompilerScope. The CompilerScope interface has three windows. The source code window, which displays the program being compiled, the IR information window, which shows the IR before and after the current transformation phase, and a flow graph information window that shows the flow graph before and after the current transformation phase. This slide shows the CompilerScope interface. This field shows the name of the function being compiled. These fields show the name of current, previous, and the next transformation phase. The information window in this picture is the flow graph information window, which shows the flow graph before and after the current phase. Note that the blocks of the flow graph changed during this phase are highlighted in the right flow graph. Clicking on the block of the flow graph shows the IR contained in that block in the code information window at the bottom. This slide shows the view of source code window. This slide shows the view of IR information window. The IR on the left hand side is the IR before the phase, and the IR on the right hand side is the IR after the phase. The different fields in the IR can be seen. The display of these fields can be changed from the display menu. The CompilerScope works with only Phoenix based compilers. We will be using Microsoft's C or C++ compiler with Phoenix backend. The CompilerScope is invoked with the command line as shown below. Here, CL is the name of the compiler that we are using. Program file is the program being compiled, and CompilerScope can be plugged into a compiler by -d to plugin command switch.